Friends, um, today I am going to explain chapter 1 Science of Standard 9. Okay, I will explain some of the important lines or the paragraph from chapter 1. First of all, let me tell you now, uh, if you have a book, you can just look at on increasing the temperature of solid, the kinetic energy of a particle increases. It is here. What is kinetic energy? Where there is a movement of objects, there is a kinetic energy. Means kinetic energy, okay, is possessed by those bodies which are always in motion, which are in motion. It is now. So whenever the temperature increases, the kinetic energy of the particles increases. Kinetic energy increases. It is here. Due to the increase in kinetic energy, the particles start vibrating with great speed. Yes, they start vibrating. Even in solid, the particles, okay, they vibrate. They're not stationary. They are always vibrating like this. It is now, they are always vibrating like this. It is. So when the temperature is increased, the particles starts vibrating, okay, more. So the energy supplied by heat overcomes the force of attraction between the particles. It is now. In solid, what happens here now? The particles are bounded very strongly. So whenever it is heated, whenever a solid is heated, that heat supplied to the solid, okay, is consumed to overcome the force of attraction among the particles. Okay, so the particles leave their fixed position and start moving more freely. They start moving more freely this year. Okay, a stage is reached when the solid melts and is converted to a liquid this year. The distance between the particles also increases when heat is supplied. In that case, what happens? When the particles are very far away from each other, the solid is converted into liquid. Okay, the solid is converted into liquid. So the temperature at which a solid melts to become a liquid, the temperature at which a solid melts to become liquid is the atmospheric pressure. Okay, at the atmospheric pressure is called the melting point. Yes, at the atmospheric pressure. Okay, when the pressure of the atmosphere is normal, at that temperature, okay, the temperature, okay, that melts a solid into liquid, and that temperature is known as the melting point. So in this blue box you can see here, so the melting point of a solid is an indication of the strength of the force of attraction between the particles. Means, what does it mean here? It means that if the melting point is very high, that means the particles are bounded very strongly into this, okay, very bounded very strongly. It is here. So in order to break that bond in between the particles, large amount of heat is required, and therefore the melting point of solid generally is high. Right? So that melting point, the melting point is the solid, is an indication of the strength of the force of attraction between the particles. Okay. In solid, the particles are bounded very strongly. In liquid, it is less bounded strongly, and in gaseous, okay, they move far away from each other. The force of attraction is the least in gases. So the melting point of ice is 273.16 Kelvin. So the process of melting, that is change of solid into state into liquid state, is also known as fusion. It is here. Yes, if a solid becomes liquid, when a solid becomes liquid, that is also known as fusion. Okay, fusion. And you know what is the melting point of ice is 273.16 Kelvin it is. You know what is Kelvin? Kelvin is a SI unit of this is temperature. SI unit of temperature is Kelvin, SI unit. And 0 degrees Celsius is equal to 273 Kelvin it is. Yes. So when a solid melts, the temperature remains the same. So where does the heat energy go? Yes. Okay, this is the important thing here now. If you heat if you heat a liter of water, if you go on heating, and the temperature of the first of all the temperature of the water will rise up to 100, and if you are continuing giving heat to this water, the temperature will still remain 100 degrees centigrade. How much you are heating, okay, the temperature will not rise up, it is here. Now the question is that, so where does the heat goes while heating? Why doesn't the temperature of the water increases? It is here. It is because the temperature, okay, is consumed, okay, to break up the force of attraction among the particles of which the solid or liquid or gases are made up of. Right? So this is about the melting point. Now next uh, the heat gets used up in changing the state of by overcoming the force of attraction between the particles. Means if you go on heating, if you go on heating, okay, the temperature will not rise. It's because that temperature is used to overcome the force of attraction between the particles. Okay, as this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the, okay, contents of the beaker and is known as the latent heat. So latent heat, it is here, latent heat. This is called the latent heat in our case. So the word latent means hidden. So the amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. This is very important here. This is the amount of from here this is the definition of latent heat. That is the amount of heat energy required, okay, that is required to change 1 kg of solid into liquid at room temperature at, at atmospheric pressure at its melting point is known as latent heat of fusion. Okay, so the particles of water, the particles in water at 0 degrees Celsius, 0 degrees Celsius means it is 273 Kelvin, have more energy as compared to the particles in ice at the same temperature. So, okay, so the particles in water at 0 degrees Celsius, okay, have more energy as compared to the particles in the same temperature. So when we supply heat energy to water, particles start moving even faster. Okay, at a certain temperature, the point is reached when the particles have enough energy to break free from the force of attraction to each other. At this temperature, the liquid starts changing into gases. The liquid starts changing into gases. Now look at the definition. The temperature at which a liquid starts boiling at the atmospheric pressure is known as the boiling point. This is an important one. It is. So boiling is a bulk phenomenon. Boiling is a bulk phenomenon, means the whole the whole water at a time is boiled, it is here now. The whole means the whole volume of the water, okay, is okay, it's boiled. So that is why it is said heating, boiling is a bulk phenomenon. Particles from the bulk of the liquid gain enough energy to change into the vapor state. Now, the for water, this temperature is to 373 Kelvin. That is okay. This temperature for water, this temperature is 373 Kelvin here, and 100 degrees Celsius is equal to 273 plus 100 is 373 Kelvin. It is, yes. So in boiling of boiling point of water, you can say in Celsius degree it is 100, and in Celsius degree in Kelvin scale this is 373 Kelvin. Yes, now turn the page. Now comes this is sublimation, the figure of sublimation. This is very important. It usually comes in the examination. Sublimation. So what is sublimation? Sublimation is change of a state directly from solid to gas. Okay. A change of a state directly from solid to gas without changing into liquid state, or vice versa. From solid to liquid or liquid to solid it is. Okay, or vice versa. Okay. From liquid to solid it will change by cooling, it is not by heating, but cooling, and this is called the sublimation. Sublimation means if you heat a solid and if it changes directly into gaseous state without going to liquid state, that process is known as sublimation. Also, if you cool down gases, then it will directly change into solid, not into liquid, directly change into solid, and this is called sublimation. So sublimation is a process in which a solid is changed directly into gaseous state without going to liquid state. So this is about sublimation. Now, effect of change of pressure. What is the effect of pressure? Okay, pressure, first of all, it decreases the volume. Pressure, okay, it decreases the volume, it is pressure. And just you can see this figure here now, show interconversion of three states of matter. This is, let us begin with solid. If we'll heat it, okay, it will change into, if we'll heat it, it will melt into liquid. Fusion means will melt into liquid, right? And if we'll, okay, and this liquid, when we'll heat it, it will, okay, convert it into gas state. And if we'll cool down this liquid gas, it will again change into solid state. So that this has been shown. You can start it from anywhere, okay, either gas, solid or liquid. You can start it anywhere, you get the same thing, it is always. Did you follow? So this is the state of matter, three states of matter, how they get changed from one state to the other state. Now, so one thing more I want to say here now, show about the sublimation. Okay, there are sublimates are there, means substances which undergo sublimation. So such as ammonium chloride. Okay, ammonium chloride is NH4Cl. It is NH4Cl, ammonium chloride. We call it Nosada in Hindi. Then it is camphor. Camphor means kapoor in Hindi we call it. So they directly changes into gaseous state from solid state. They never goes to liquid state. That's right. Now, one more thing I just want to say about the states of matter here now. So, look at we generally know that so there are the three states of matter. One is the solid, liquid, and gases. But besides these three, two more are there, and they are known as plasma and the Bose-Einstein condensate. Okay, condensate. This is known as Bose-Einstein condensate, and the first, and the other is a plasma. It is a plasma. So what is plasma? Okay, a state consists of super energetic and super excited particles. Yes. Super energetic and super excited particles. So these particles are in the form of ionized gases. Ionized gases. Do you know what is ion? A charged particle is called ion. So the fluorescent tube and the neon tube, okay, consist of plasma. Okay, they, in a test tube we do have test tube in our homes, so that contains ions. It is ions. Okay, ions, ions of gases. So inside a neon sign bulb, so there is a neon gas, and instead of fluorescent tube, so there is a helium gas or some other gases. Okay, helium gases or some other gases. So they're used, okay, in tubes to give a different, different colors it is. So this charging up creates a plasma growing inside tube or the bulb. So plasma glows with a special color depending on the nature of the gas. Yes. Okay. The sun and the stars glow because of the presence of plasma in them. So the plasma is created in stars because of very high temperature plasma. So that is a state in which the particles are found in ion form. Okay. So plasma is that state of matter in which the particles are found in ion state, ions. Second is the Bose-Einstein condensate. So in 1920, Indian physicist Satyendra Nath Bose had done some calculations for the fifth state of matter. Fifth state of matter it is here. So this is the fifth state. So building on these calculations, Albert Einstein predicted a new state of matter, the Bose-Einstein condensate. Just to honor Einstein, okay, and just to honor this Bose, okay, that particle was named as the Bose-Einstein condensate. In 2001, Eric A. Cornell. So this is the name given here now. There was scientists who discovered this. So today I am stopping it only this much. Then in next class I'll make some more video.